How do we find distance and midpoints in 3 dimensions? Well, it's pretty much going to be the same way that we find distance and midpoints in 2 dimensions. Recall that this is our midpoint formula in 2 dimensions. We're taking the average of the x-coordinates and the average of the y-coordinates. In 2 dimensions, the way we calculate distance is we do Pythagorean theorem, take the square root of the change in x squared plus the change in y squared. So this is subtraction, this is addition, and each of them must be squared first before calculating the distance. In 3 dimensions, the process is identical, except now we have an extra coordinate. So we're still taking the average of the z-coordinates, and we'll still take the square root. It's still square root, we're not taking cube root, it's still an exponent of 2, we're just adding an extra change in z squared under the radical. So, find the midpoint and distance between these 2 points. So the midpoint, I'm going to do the midpoint first. We're going to take the average of the x-coordinates, 3 minus 3 over 2. The average of the y-coordinates, 1 plus 5 over 2. And the average of the z-coordinates, 5 plus 9 over 2. So that's 0. 6 over 2 is 3. And 14 over 2 is 7. So that's the midpoint. The distance. So we're going to do subtract the x-coordinates squared, subtract the y-coordinates squared, subtract the z-coordinates squared, and then we get negative 6 squared plus 4 squared plus 4 squared, which is 36 plus 16 plus 16. This is going to be, let's see, I believe 68? Yes, 68. Square root of 68. Can we simplify that further? Yes, those are both divisible by, it's divisible by 4. So then we get 4 and 17. So 2 square roots of 17 is going to be our distance. Another example. The midpoint and distance between these points, we're going to take the average of the x-coordinates, the average of the y-coordinates, the average of the z-coordinates. So we get negative 4 over 2, 12 over 2, and 6 over 2. That's the midpoint. The distance, we're going to take x2 minus x1 squared, y2 minus y1 squared, and z2 minus z1 squared. So you have 6 squared plus 4 squared plus negative 4 squared. Was this the same value? I think it was. 36 plus 16 plus 16. Yeah, we did this in the previous problem. It happens to be 2 squared to 17. It's not usually going to be 2 squared to 17. I just randomly chose numbers that ended up giving the same result. So 3D midpoint and distance, same as 2-dimensional, just extend it a little bit.